Good morning, students. Welcome to our mathematics class. So today I am going to discuss to you solving radical equations. And our learning competency for this topic is solves equations involving radical equations. And our learning objective, solve radical equation. Okay, before anything else, let's define radical equations. So what is radical equations? It is an equation in which the variable appears in a radicand. I will give you examples. Examples are A, square root of x is equal to 7, B, square root of x plus 2 is equal to 3, and C, square root of 2x minus 3 is equal to square root of x plus 5. In solving radical equations, we can use the fact that if two numbers are equal, then their squares are equal. In symbols, if a is equal to b, then a squared is equal to b squared. Examples are if square root of 9 is equal to 3 are equal, so using squaring property of equality, so in short, we're going to square both sides of the equation. Then quantity square root of 9 squared is equal to 3 squared. So they are equal. Then transform the base of the left side to exponential form. Okay, this one I'm going to show you. We're going to transform this left side of equation into exponential form. So that's why this will be a quantity 9 raised to 1/2 raised to the second power. And also, it's equal to 3 raised to the second power. Okay, now we have 9 raised to 2 over 2 because when you multiply 2 by 1/2, we have 2 over 2 power. And then the result is 9 is equal to 9 because when you divide 2 by 2, this one, and any base with the first exponent of first power, therefore this will be the result, the base itself. For our second example, if square root of x plus 2 is equal to 3, then squaring property of equality, we have the square of the quantity square root of x plus 2 is equal to the square of 3. After squaring the left and the right side of equation, then we're going to transform to exponential form. So transform the left side of the equation into exponential form. So what we're going to do here, we have squared of the quantity x plus 2 raised to 1/2. So changing to exponential form, for our base, we have quantity x plus 2 raised to 1/2. And also the squared is equal to the squared of 3. Then after that, we're going to apply the power rule, which is power to a power for the exponents of the left side of the equation. So what will happen is, yes, so we have what we call this the power to a power rule. 1/2 times 2, or 2 times 1, we have 2 over 2. And then simplifying, 2 divided by 2 is 1. So it's in the first power. So we're going to write x plus 2 is equal to 9. Okay, after that, in order to get or to find the value of x, we're going to add what? Okay, add negative 2 to both sides of the equation. So here and there. Okay, for what reason? Okay, because we're going to eliminate 2 in order to retain x to the left side, and this is what we call inverses. So applying inverses or additive inverse, so we have to cancel positive 2 plus negative 2. Okay, this will be 0 now. Okay, so we have x for the left side because 2 minus 2 is 0, and then rewrite 9 minus 2. Then subtracting 2 from 9, the answer is x is equal to 7. So our solution for our example number 2 is 7, or x is equal to 7. So to check, so let's try to check. We have the original equation here. Okay, from there, so we have the square root of x plus 2 is equal to 3. Our value of x is 7, so make it 7 here. So we have the square root of 7 plus 2 is equal to 3, and the sum of 7 plus 2 for the radicand is square root of 9 is equal to 3. And it's very obvious the square root of 9 is equal to 3. Then we have 3 is equal to 3, and that is the correct answer. So our solution for this example is correct. Okay, class, you have to take note this. If the squares of two numbers are equal, the numbers may or may not be equal, such as the square of negative 3 is equal to the square of 3, but negative 3 as base is not equal to 3. It is therefore important to check any possible solutions for the radical equations, because in squaring both sides of a radical equation, it is possible to get extraneous solutions. But what is extraneous solutions? So we're going to clarify this part to our next video lesson. So that's the end of the first part of our video. So here is our reference. Okay, thank you class for watching. See you next time.